What do you think should be the next steps of humanity when we have something that we agree that, yes, this is not of Earth? What would you say we should do?
If we detect signal or find a piece of equipment that indicates another civilization, it would be prudent to figure out what the purpose of this. What does it imply about the intentions of the other civilization? Because when you go in the wilderness, you want to listen and figure out if there are predators out there, and that could risk your existence.
What's up, Auxoro Premium Gang? I'm here in this beautiful apartment in Maastricht, Netherlands. Highly recommend checking this place out. Coming off of a weekend in Amsterdam that was wild. I went there with my partner, and I'm spending the next couple weeks here, spending about a month total in Maastricht, Netherlands. It is a hell of a time, great city to get work done and also explore food, drinks, and people. I wanted to thank you guys for supporting the premium podcast, Auxoro Premium. You are a huge part of why I'm able to do the show, and from the bottom of my heart, thank you for your support. This time I sit down with Avi Loeb. Avi is an astrophysicist from Harvard, an author, and someone with great enthusiasm for what he does. In his book, Extra-Terrestrial, the first sign of intelligent life beyond Earth, Avi explores the story of Oumuamua, the possibility of alien life and alien technology visiting our solar system or having already visited our solar system. And Avi also dives into his own life in the book. In this episode of the podcast, Avi and I get into the question of, are we alone in the universe? The story of Oumuamua that he describes in the book, what we should do if aliens decide to make first contact, the movie Arrival, the beauty and flaws of science communication, and much more. Avi's book is well worth your time. I believe that this conversation is also well worth your time. And without further ado, I will not waste any more of your time and bring you this deep dive with Avi Loeb. Okay, so Avi, thanks again for taking the time to sit down on the podcast. I figured we would jump right into it. And the first video that I actually saw of you before I read your book was a TED Talk called The Case for Cosmic Modesty. And you asked the question, are we alone? So I will ask the question to you, like you asked the audience at your TED Talk, are we alone?
Well, first, thanks for having me. It's a great pleasure to speak with you. I learned one lesson from decades of practicing astronomy, which is a sense of modesty. And the reason I say that is we are born into this world like actors put on a stage. And at first we think the play is all about us. And that goes back to the ancient Greek philosopher Aristotle that argued that we are at the center of the world, there are spheres around us, we are really playing a central role in this play. And people believed him for 1,000 years, and then Copernicus and Galileo Galilei realized that in fact the Earth moves around the sun. We are not at the physical center of the universe. And if we actually look at the universe nowadays, we see that it's huge. It's 10 to the power 26, or 1 with 26 zeros after, bigger than the size of our body. So that's the stage that we can see. In fact, the stage may extend even farther than that. So the stage is huge. And moreover, the play has been going on for 13.8 billion years. That's the time since the Big Bang. And it may have started even before the Big Bang. So clearly we came to the scene relatively late. It's not about us. That's the biggest message.
So Earth came onto the scene. Our galaxy came onto the scene pretty late in terms of the other solar systems that have been in existence.
Right. So if you look at the star formation history of the universe, most of the stars formed billions of years before the sun. And if there was something similar to us around them, and by the way, that's a good bet, because we know now that about half of the sun-like stars had a planet the size of the Earth, roughly at the same separation. So if there were civilizations like ours that predated us by billions of years, we are relatively late comers to the scene. And in principle, if some of them are around, we could approach them just like we approach other actors in the play to check out what the play is about. We should approach the world with a sense of modesty. We are not important. We're not central. That's the biggest mistake the humans have made, to think that it's all about us. I can sort of understand it, because when I looked at my daughters when they were young, they were at home and they thought the world centers on them and that they are the smartest. And once they went to the kindergarten, they had a psychological shock. And on the first day of their kindergarten, I'm sure if I would have asked them, they would prefer to stay at home, because that would maintain their illusion of being the smartest. And we act pretty much like my daughters, and the same was true about Aristotle. But I think we should mature and realize that it's not about us, and we just need to learn from what's out there.
Yeah, it's funny how so many people, and I would consider myself as part of this conversation until recently, but so many people consider the idea of alien life absurd simply because it seems absurd to think about. But then when you take into account that there are other planets that have the same conditions or similar conditions to Earth, that are similar distances away from a star like the sun, it's unimaginable. There are billions of similar planets. I think you mentioned it was like 10 to the power of 20 planets that are similar conditions of Earth. And
Right.
When I think about that, I think about sports, because I grew up playing sports. And for example, LeBron James, someone sees a player like LeBron James and they say, there is never going to be another player like LeBron. He's the only one that's ever going to exist. He's special. But you look at the other situations that can cultivate a player like LeBron. There are other neighborhoods that are similar around the world where he grew up in, where there are kids that practice basketball and you could scrimmage other players in basketball. Maybe they're poor neighborhoods where there are kids that basketball, they may see it as their only way out. There are other people that have genetics like LeBron that can lead to someone else being like him and achieving the success of him. So when you think about something like sports, it doesn't seem absurd that a once in a lifetime thing can happen again. But then the sheer, I guess it's something about the sheer vastness of the universe or the mystery, where people kind of turn off to the possibility of alien life. Because we don't do that on Earth. We see something and we're like, oh, that, the right conditions, that could possibly happen again,
Yeah, it's a matter of common sense to say that under similar circumstances you get similar outcomes. And I would not even compare us to LeBron James, because I would argue that we are most likely to be just like ants on a sidewalk. There are many of them. None of them looks particularly special, and that's why nobody cares about us. Nobody pays a visit. That's Fermi's paradox. Enrico Fermi, about 70 years ago, argued, if they are out there, why don't we see them? And the point is, that's a bit presumptuous to think that we are special and unique and deserve attention, because the conditions here are replicated in so many other places. And actually, if you watch the news every morning, you realize that we are doing a lot of foolish things. We are wasting resources on fighting each other, feeling superior relative to each other. In my book, Extra-Terrestrial, I talk about the Second World War. And, Winston Churchill, he got the Nobel Prize in Literature and wrote an essay in 1939 arguing that it would be fascinating to search for technological civilizations out there. And he didn't have a chance to publish his essay because he was recruited to become the prime minister in England and fight the Nazis. And just think about the Second World War, how many resources were wasted in killing people and just fighting racism. If this would not have happened, if all of the same, just imagine another world where the same resources would have been dedicated to Churchill's essay, trying to search for other intelligent civilizations, then we would have known the answer by now. So the point is, we are doing non-intelligent things. We are wasting resources for nothing. There was nothing good that came out of the Second World War, and that shows that we are not particularly intelligent. I define intelligence as promoting the best future, and obviously we are not doing that. We are not cooperating. Science is really about cooperation. Science is really the future of humanity, in the sense that it's an infinite sum game. In economics, people talk about zero-sum game, where if someone wins, the other person loses. But in science, if you gain knowledge, everyone benefits from it. And so cooperation is really the fundamental principle of science: sharing information, sharing knowledge, and creating new knowledge is really the essence of doing science. So I think if we were an intelligent civilization, we would invest all of our resources in science rather than in defense or the military and so forth. And we would work together to figure out how to make the future better. Just think about the pandemic, as an example. It's quite amazing that within a year, a vaccine was developed. And I'm talking about the mRNA in particular, the vaccine that is completely synthetic, not a weakened virus, but something that is based on our understanding of how things work. And within a year, it brings people back to normal. It's quite amazing.
To push back a little bit, so you think that it would be better to dedicate everything to science and not as much to defense, or nothing to defense?
Well, if you are a realist, then of course you have to worry about other nations not doing that. Therefore, you have to protect yourself.
Yeah.
Right.
So
But
when we're
I'm
going
talking about humanity as a whole. Suppose this realization would be recognized by all nations. Then we can all do it together. You are right that you can't just do it on your own and then assume that others will behave properly. That will not work.
It seems like it would be a smart thing to, obviously, realistically, you have to continue to develop defense mechanisms for bio attacks, for technological attacks, warfare, and it seems like it would be a good idea to continue to develop defense mechanisms alongside our search for extraterrestrial life, because the extraterrestrial life may not be kind to us. We may need to be in a position where we need a peaceful planet. We need people to come together and have a unified mission to accomplish multi-planetary existence, and at the same time have weapons that are capable of enormous destruction, just in case another civilization or something else comes along where we need to use that.
Yeah, that's one way of looking at it. So if you think about what our neighbors might be, if there is a smarter kid on the block, so you have to worry about predators. When you go into the wilderness, you don't speak out very loud because you want to listen and see who is out there. And unfortunately, we have been broadcasting radio waves for more than a century. So if there is another civilization that has radio telescopes of the type that we have within 100 light years, they already know about us, and we have to worry that they don't have any aggressive agenda. And as you say, we need to be prepared to protect ourselves. But I do hope that it will bring, if we recognize that there are others out there, it will bring people together. So that's one aspect of it, protecting ourselves, as you point out. But there is another. Suppose they existed much longer than we did, and it's quite possible that they have peaceful agenda. At any event, we can learn from their technological accomplishments, because that represents our future. So if there is equipment that we identify in space that came from outside the solar system, first of all, we want to identify it by taking a close-up photograph. If we have an interstellar object like Oumuamua that looks weird, this is the object I describe in my book, Extra-Terrestrial, the first interstellar object that we discovered. If another one comes along and it looks as weird, we want to send a spacecraft with a camera that will take a close-up photograph. And if it does look like it's artificial and doesn't look like a rock, a naturally produced object, then we want to land on it. And if we do land on it, like OSIRIS-REx, this mission that landed on the asteroid Bennu and took a sample from it, if we land on it, we can first read off the label made on planet X, just try to figure out where it came from. But we can also, if it represents a technology that we don't possess at the moment, that represents our future, we could import it to Earth. And from a business perspective, that could be worth a lot of money, because it represents a future technology that will take us a while to develop ourselves. So we can learn from them. That's my other lesson. My other point, that it's not just about protecting ourselves, it's more about also learning from their technologies. And if they are not around anymore, if they just sent equipment and they have died by now, we want to learn a lesson from their history so that we don't replicate their mistake and we don't share the same fate.
Yeah, we can learn from their trash, like you say is a possibility for what Oumuamua is, a trash from another alien civilization. Before we get into that, which we will, we're going to dig into Oumuamua, I wanted to go back to the basketball analogy for a second and ask you, if you take everyone on a spectrum from the worst pickup basketball player to the best basketball player in the world, LeBron James, where do you think humanity is on that scale in terms of proficiency, intelligence, being interesting to other civilizations? Where do you think we fall from the worst pickup basketball player to the cream of the crop civilization?
Well,
like
I
dunking on
think that
people.
we're sort of near the average, simply because if you look at recipe books and you realize that out of the same ingredients you can get many different cakes, and most of the time you get the average cake. And the early Earth had some chemicals on it, and they randomly made the life that we see on Earth that ended up in us. I would assume that we are probably the average cake that you can get out of these chemicals. And if you do it billions of times on other planets, we're probably not the outliers. That would be my guess. Again, out of modesty. So compared to a basketball player, I would say that we are sort of an average basketball player. We're not LeBron James. But the only way to find out is to search for more players, and try to compare ourselves to them. And one thing to keep in mind is our technologies are evolving on a few years timescale. And they evolve exponentially. So just imagine a civilization that was longer lived than our technological civilization. If instead of 100 years of technology development, they had 1,000 years, they would be far more advanced than we are, irrespective of how intelligent they were to start with. So I think it's not just in terms of, how intelligent they were to start with, but also how much longer they had lived compared to us. And that's why, since we're relatively young, only a century old in terms of our technologies, I would guess that, a century is just one part in 100 million of the age of the universe, or the age of the sun. So I would think that there must be civilizations that are much more advanced than we are.
Yeah, it's crazy to think about how humans have been around for over 2 million years, and yet we've only hit this technological boom 120 years ago. And so we're mature species, but technological babies. And so if someone was going to communicate with us, we would have to have similar technologies that allow us to both receive communication and send communication. So that means some other civilization that was within distance of reaching out to us would have to be in that same phase of technological innovation where like they have radio or similar things that we have to fire off satellites into the ether, and then we'd also have to have similar technology to receive it. Is that correct, or does that make sense?
Yeah, so that's one explanation for why we haven't detected signals, because there is a relatively narrow window of opportunity, just maybe of over a century or so. We are already developing, we are into cable communication rather than radio communication, and within a century from now, maybe radio communication will be completely obsolete, and so and more than that, it's possible that we would not survive for more than a few centuries. I was asked at the Harvard Alumni Forum a couple of weeks ago, how much longer do I expect our civilization to last? And the point is, if you ask yourself, suppose you choose a random day throughout your life, what's the likelihood that it's the first day after you were born as an infant? And the chance is 1 in a few tens of thousands, because most likely you will find yourself during the time that you're an adult, because rather than the first day of your life, because there are tens of thousands of days in the life of an adult. And so the chance of you being in the first day of your life is 1 in several tens of thousands. And the same is true for us as a technological civilization. We've existed for a century. So if we are now during our adulthood, we have a few more centuries, and that's it. The likelihood of us lasting millions of years is, again, 1 in a few tens of thousands compared to the century that we lived through. And therefore, my answer to their question was probably we just have a few centuries left. We are much more likely to be in our adulthood. Unless, of course, we get our act together and, there is the human spirit that can decide to be an outlier of the statistical verdict and decide to, for example, go out to space. And currently all our eggs are in one basket here on Earth, but in principle, if we go to space and spread our eggs in many baskets, we might last much longer than a few centuries. So it's really up to us and our ambitions as to how much longer we would last.
Yeah, I guess the devil's advocate position for that would be that we don't have any civilizations like us that we've discovered yet to see how they've gotten through these seemingly disastrous choices that we may have made with climate or nuclear energy. There may be some sort of switch that other civilizations go through, or some jump in maturity level or coming together that we just haven't hit yet, or we haven't been in that space yet. Maybe it's in the future with something like artificial intelligence that, that's a whole nother realm on its own. But it could just be that we also are kind of in the sauce of figuring out how to do that now and how to see a future and figure out we're technological babies. So if you hand a nuclear weapon to a baby, or you hand artificial intelligence to a baby, they might not know how to use it for 15, 16 years in human years, which could be thousands of years or maybe millions of years for humans. So we could also be in that phase as well.
Right. But the point, the good news is that if other civilizations figured out how to last much longer, and they have some recipe for that, as you say, the good news is that the ones we will find are the ones that survive. So they are, according to Darwin's principle, the survivors, those that lasted, that managed to maintain their longevity, are the ones that we will be able to learn from, because they will be around and we can ask them or communicate with them. So that's the good news, that there is this selection.
Yeah. Speaking of learning from other civilizations, can you tell the story of Oumuamua? What is Oumuamua? How did you find it? Is it of this world? And kind of the backstory of how this object came to be as you see it.
Right. So this object, Oumuamua, was discovered on October 19th, 2017 by a telescope in Hawaii on Mount Haleakala that surveyed the sky. The telescope is called Pan-STARRS, and Oumuamua was the very first object discovered from outside the solar system near the Earth. And the reason we knew that it came from outside the solar system is that it was moving too fast. It couldn't have been bound to the sun. So unlike the planets that are gravitationally bound to the sun, this object was definitely not bound. It came too fast to be trapped by the gravity of the sun. And so it was the very first interstellar object, an object that came from in between the stars, not from the solar system itself. But the astronomers thought, oh, it must be just like the rocks we had found in the solar system, except it came from another star. Unfortunately, this was not the case. It didn't look like the object behaved like either an asteroid or a comet, the type of objects that we have seen within the solar system. It wasn't a comet because we haven't seen any gas around it. There was no dust or gas trailing it. There was no cometary tail, and the Spitzer Space Telescope looked very deeply and couldn't find any traces of gas to a very significant limit. And then as it was tumbling, as this object was tumbling over 8 hours, it reflected sunlight, and the amount of sunlight that it reflected changed by a factor of 10. And that meant that the object has an extreme shape, most likely flat, pancake shaped. And then another weird property of this object was that it was pushed away from the sun by some other force, in addition to the force of gravity that affects its trajectory. And the only additional force that I could think of was the reflection of sunlight. Mm-hmm. And indeed, that force behaved just like you expect for reflection of sunlight. But in order for the reflection of sunlight to be effective in pushing the object away from the sun, you need the object to be very thin, to have a large area for its mass. And that meant that it should be something like a sail, except not being pushed by the wind, but being pushed by reflecting light. That's called a light sail. And nature doesn't make thin objects like that, doesn't make sails. So that I made a suggestion in a scientific paper that it may be a light sail. And as it turns out, in September 2020, just over half a year ago, there was another object that exhibited the same behavior of being pushed away from the sun without showing a cometary tail. It was given the astronomical name 2020 SO after being discovered by the same telescope in Hawaii, Pan-STARRS. And shortly afterwards, astronomers realized this object actually came from the Earth. It was a rocket booster that was launched in 1966 as part of a lunar lander mission. And we know that we produced this object artificially. And it was thin, it had thin walls compared to its mass. And therefore it was pushed by reflecting sunlight. Obviously without a cometary tail. So we know that this object was artificial and the same of the same qualities as Oumuamua. The question is, who produced Oumuamua?
So it shares some characteristics of other naturally occurring objects, but nothing fully. So that there are things that it does that are like comets or like asteroids or like other things that we've seen, but it does no one natural explanation has revealed itself through evidence. Is that correct to say?
It didn't look like a comet because it didn't have a cometary tail, so it was definitely not a comet. Then in terms of being an asteroid, an asteroid without a cometary tail doesn't show an excess push away from the sun. So it wasn't an asteroid and it wasn't a comet. So then the question was, what is it? Some astronomers try to explain it from a natural origin, and there were about 4 suggestions for a natural origin. All of them contemplated something that we've never seen before. For example, a collection of dust particles, a dust bunny, 100 times less dense than air. And the problem with that is when it comes close to the sun and it gets heated by hundreds of degrees, it will not maintain its integrity. That's the problem. There was another suggestion, maybe it's a hydrogen iceberg, a chunk of frozen hydrogen. And so when the hydrogen evaporates, it creates a cometary tail, but you can't see it because hydrogen is transparent. And the problem with that is that the hydrogen iceberg will get evaporated along its journey and not reach us. We showed it in a scientific paper. It won't last very long. Then there was a suggestion, maybe it's a nitrogen iceberg, chipped off a surface of a planet like Pluto. And the problem with that is the mass budget. We showed it in another paper. There is very little mass in solid nitrogen on the surface of Pluto. So if you imagine a lot of planetary systems that have a lot of Plutos that are chipped off, it's just impossible to get enough of those chunks of nitrogen to explain an object like Oumuamua, because the abundance of these objects will not be high enough for us to see one of them with Pan-STARRS. So that doesn't work either. There was another suggestion, maybe it's a piece of a bigger object that passed close to a star, but that would be most likely elongated, like a cigar rather than pancake shape. So all of the suggestions that were made invoked something that we've never seen before, and all of them had some problems, some issue, some flaw. And so my point is quite simple. If it's something we've never seen before, why not allow for the possibility that it's of artificial origin, that it was manufactured by a technological civilization?
Yeah, that's interesting. When I was reading your book, Extra-Terrestrial, I was thinking about the God argument, because I grew up as a Catholic. I went to church, and one of the things that kind of drew me away from Catholicism is that everything that we don't know is put in the bucket of God. So if it's a mystery, you just like drop it in the God bucket, and we don't know how this is happening. What if this is just a naturally occurring thing that we haven't understood yet? And when I was reading the book, it occurred to me, and I was thinking about, okay, so there's all these pieces of evidence, and you drop it in the bucket of it being from an intelligent civilization. You write the simplest explanation is that the object was created by an intelligent civilization, not of this earth, and you provide a ton of evidence to back it up, and you do it so beautifully in the book. And I was thinking, why are you choosing to drop it in the bucket of alien intelligence or another type of intelligence? Why not drop it in the bucket of naturally occurring thing that we may not understand yet?
Well, that's a possibility, but my point is, science is driven by evidence. So first of all, I went in that direction because the evidence looked anomalous. It didn't look like anything we've seen before. And obviously, all the other alternatives that were proposed by other scientists also invoke something that we've never seen before. So that it's clear that everyone agrees that it should be something we've never seen before. Now, how can we tell if it's natural in origin or artificial in origin? That's the fundamental question. And the best way to find out is actually looking for more objects of the same. And when we find another one that is on its approach to us, sending a spacecraft with a camera that will intercept the orbit, the trajectory of that weird object, and take a close-up photograph. Because, they say a picture is worth 1,000 words. In my case, a picture is worth 66,000 words. The number of words in my book.
Yeah.
I wouldn't need to write a book if we had a photograph. So, it's just like any other scientific question. And you can make progress by getting more evidence. Now, if
What
you
was the reason
say,
why we weren't able to send something to take a photograph? Is it that we didn't have enough warning? Do we have the technology to do that? What was the reason why we weren't able to get a close
yeah.
up picture?
So the first reason, it was moving very fast, much faster than any rocket that we can launch. Okay, so and we discovered this object when it was already receding away from us very fast. So sort of like finding a guest that came for dinner, and finding that guest interesting once it leaves through the front door into the dark street. And by
Yeah.
now Oumuamua is a million times fainter than it was close to us, and so we couldn't really chase it with existing spacecraft that we have. And
So if we did get a picture, it would be like getting a blurry picture of Bigfoot, basically. Like it wouldn't be
no,
that
no,
clear at this point.
it's different. It's different in the sense that the object is roughly the size of a football field, about 100 meters or so. And at the distance that it was, which was like a fraction of the Earth-Sun separation, the telescopes that we have on Earth just cannot resolve it. They're not, you just cannot resolve it into multiple pixels. You just see a point source of light. So you can't really tell what it is. But the way to resolve it is to come close to it so that you can see, you can have multiple pixels across that the object, and you don't just see it as a point of light. And the only way to do that is by sending a spacecraft that comes close to it. We can't resolve objects of that size from Earth. We just don't have big enough telescopes at the moment. And so the point is, if in the future, instead of seeing something when it leaves our neighborhood, we identify an object like that when it comes into our neighborhood, when it approaches us. And in principle, we can do that with Pan-STARRS, that telescope. But in fact, in 2 years, there would be a new telescope called the Vera Rubin Observatory that is much more sensitive than Pan-STARRS, and could give us an alert a year in advance before the object gets to us, of an object of the same size. And then we can design a spacecraft that will intercept the orbit, the trajectory of this object, because we can forecast exactly where it will go, and then take a close-up photograph. And that's really the trick. So, in science, the beauty of science is you don't need to argue about who is right based on some, who expresses the arguments better, or based on some prejudice or whatever. You don't need to get a lot of likes on Twitter. That's not really the issue. The issue is getting evidence, and there is a simple experiment we can do with the next one that comes along. We can send a spacecraft taking a photograph, and then I think everyone would be convinced by what the photograph shows. And if it doesn't look like a natural object, that would be amazing, because then we can plan to land on it.
Yeah, with the way human civilization is going, if we were able to get a photograph up close with Oumuamua in person, it would be a selfie with Oumuamua in the background. Someone would post it on Twitter and it would go viral, and that's how people would find out.
Yeah. I mean, it could have. You can imagine a situation where it looks just like a rock, an unusual rock of the type that people contemplated, like a hydrogen iceberg or a nitrogen iceberg or a cloud of dust particles. Maybe it is something like that, but it would still teach us something really new that we've never imagined objects like that before. However, if it looks artificial, like a light sail, it would be even more amazing. So, and by the way, I asked once the students in my class, I asked them, would they be, suppose a spacecraft were to land on Earth, would they be willing to board it and take a one-way trip? And they all said yes, as long as they can share their experience on social media. And I found that condition to be rather strange, because if I was next to aliens, I wouldn't care less whether other people share my experience. It's just like climbing the Himalayas. I would enjoy the thrill of just doing it myself.
Yeah, look, I think, the first generation of people that we send to explore another planet is going to be TikTok stars, so that we can have people dancing on other planets and showing it off. And so, I understand the students' crazy desire to. I don't agree with it, but I understand the desire to want to, show off everything. It seems like social media is so ingrained in everything we do, and sometimes I'm guilty of myself. Sorry for the sirens in the background, but sometimes I'm guilty of myself thinking about the value of something through social media or the ability to show it off, and then I have to smack myself and be like, just do it to do it. So yeah, that's another dynamic. It'll be interesting to see how the discovery of alien life maps out through social media, because that's a whole nother interface that discovery will have to pass through. Like, will people dance about it? Will they tweet about it? Like, what's going to happen? Are people going to try to vlog it to make contact? So we'll see.
Well, the problem I have with social media is reminds me of the beach. You see seashells that each of them looks distinct relative to each other when they are put there on the beach, and they have different colors, different shapes, and they look unique. But over time, these seashells rub against each other because of waves that are passing by, and when they rub against each other, they start to break up and they lose their color, and they become indistinguishable from each other. They turn into the sea sand that we see, grains of sand that are indistinguishable from each other. And that's the problem I have with social media. When people rub against each other on social media, they start to become indistinguishable from each other. And I don't like that. I do prefer to see each person on his or her own. What Oscar Wilde said is, be yourself, everything else is already taken. And if you go back to the ancient Greek philosopher Socrates, he was advocating for dialogues, trying to figure out what the weak points are in the arguments of public figures or people in general, and he was accused of corrupting the youth and of not believing in the gods of the state of Athens at the time, the city-state of Athens, and he was sentenced to jail and eventually was executed by drinking poison, simply because he didn't subscribe to the gods of the state. And that was a democratic state back then. That's where democracy was born, in Athens. And he was executed by drinking poison. Now, nowadays,
luckily you only get banned nowadays. You don't have to drink poison if people don't like you.
So I think what would have been the substitute for the poison that he had to drink would have been for him to be cancelled on social media by the Athenians of the time, and he would have been instead of drinking poison, he would just be cancelled on social media. That's all.
Yeah, I do think there is a way to use social media as a tool and also stop yourself from becoming like everyone else, like the seashells rubbing together. I know my own social media experience, which is I see wild shit every day on social media, and I try to take the things that inspire me. I try to steal ideas from my favorite creators and then apply those to podcasting in a way where it started with an inspiration that I saw on social media, and then I'm taking it and putting it through my own filter and trying to add to it and make it my own thing. So that is a constant battle on social media, trying to be your own person and be your own creator, and also stop comparing yourself or stop trying to be like someone else because you see they have more followers, or that you want their life, when in reality, they're them because they just tried to be them.
Right, and the other point I would like to add to that is, from it's just like basketball coaches advise their team members, keep your eyes on the ball rather than on the audience. And in terms of the ball, from the point of view of a scientist, the ball is really the evidence, the
Yeah.
data. And if something looks unusual based on the data, people prefer to stay in their comfort zone and basically advocate for notions that they had in the past. So they resist change. But if you pay attention to the anomalies that the data shows, then you are more likely to be close to the truth, and that's what I did in the case of Oumuamua. I was guided by the evidence rather than by what my colleagues say.
Yeah, to go back to Oumuamua and the evidence, you talk about the path of Oumuamua and the deviation from that expected path as the root of a lot of mystery that surrounds it. Can you talk about that path and the gap between what you expected an object like Oumuamua to do and what actually happened, what you actually observed with the evidence?
So Oumuamua showed about 6 anomalies, but the one that convinced me to write this paper that suggested maybe of artificial origin is really the excess push away from the sun, and that created a deviation from its original path if it were dictated just by gravity, the gravitational force of the sun. And the deviation was significant because if, for example, it was a comet that would have evaporated, and then the evaporated gases would have given it the excess push through the rocket effect, you needed about 1/10 of Oumuamua to be evaporated, the 10%. It's a lot, and we would have seen that gas and dust if it was a regular comet easily. We haven't seen that. So 10% is a lot, and you can't just brush it and say, oh, maybe it's a small amount, we haven't seen. No, the limits on any gas around it in the usual form are much tighter than that.
Is it possible that the 10% that disappeared, we may not have had a good angle to see it? Is it possible,
no.
if I lost 10% of my body and maybe I was standing at an angle where you couldn't see it in a photo, could it be something like that, or no?
No, because the angle that we viewed this object changed over time. It moved around us, and basically you see cometary tails as a result of them reflecting sunlight. So it just depends on the composition of the tail, and if it has dust or water vapor, we know that we can see those things quite easily, or any carbon-based molecules. And in fact, the Spitzer Space Telescope looked very deeply for carbon-based molecules and put very tight limits that are orders of magnitude below what's needed to push this object the way we saw. And so, of course, if the measurement of the deviation from the trajectory was wrong, then all bets are off. But I checked that inference, and it looks reliable to me based on the data that was reported. That's the way science is done. There is some data being reported by observers, and you just look at it and you realize, well, it's very puzzling what happened to this object. And that's why the scientists that tried to explain the properties of the object had to invoke something we've never seen before. And to me, the fact that the first object that we see is unusual is noteworthy because it means that it's common, it's not rare. There was a second object discovered from interstellar space, and that looked just like a comet. We saw the cometary tail, it was called Borisov. And people asked me whether that convinces me that Oumuamua was also natural, given that Borisov, that second object, looked like a comet and was probably natural. And I said, well, if you go along the beach and you see a plastic bottle, and then after that you see a rock, that doesn't make the plastic bottle a rock. When I met my wife, she looked special to me, and I met a lot of people afterwards. It didn't change my impression that she's special.
Yeah, Yeah, it doesn't it doesn't take away from the fact that something is special just because you haven't seen it before, or maybe if you have seen it before. Um, so 10 years from now, if there was evidence that showed, for the sake of a thought experiment, if 10 years from now it was concluded that evidence showed Oumuamua was indeed a naturally occurring object, what would you say is the candidate for the most likely type of naturally occurring object it could be? If you knew 10 years from now it was, looking from what you know right now, what would you bet would be the outcome? If you had to place a bet.
Okay, if it was naturally produced of the, I would guess the measurement of the excess push away from the sun was wrong. That measurement.
Okay,
that was
interesting.
by
So the
observers.
measurement, you'd go with the measurement being wrong, and the excess push would have been something more like a comet or an asteroid.
No, so there was, my best bet would be that there was no excess push. That in fact the measurement that was reported by the observers, there was something wrong in the data that was reported, that there was some systematic effect in the measurement that was not appreciated, and as a result there was no excess push. So if you take away the excess push, the only anomalies you are left with is the object had a very peculiar shape. It was pancake shaped, a very extreme, 10 times longer than it is wide. But you can still live with that. You can say, okay,
Yeah.
maybe it's very unusual rock, not a comet, because we don't need a comet. We didn't see a cometary tail. We didn't see an excess push in the case that it was wrong. And you just need to explain the very strange shape, and also the fact that the object came from a special frame of reference. We didn't talk about that. I discuss it in my book. But these things, you can sort of say, okay, it's unusual, but it's not extremely unusual. So I would be able to live with that. And in fact, when we didn't yet know about the excess push, I didn't plan to say that this object is unusual, that this object is artificial. So that would be my bet. Now, if indeed there was an excess push, I would say all bets are off, and we need to find out. I don't have, I would think that the artificial origin is quite a significant possibility, and we need to explore it with more data on objects that look as weird as this one.
Yeah. Is there something, you mentioned the frame of reference? Is there something interesting? Because you go into a lot of detail in the book, and anyone interested should go check out Extra-Terrestrial for the full 60,000 word evidence-based explanations of Oumuamua. Is there anything interesting you could say now about the frame of reference to give people kind of a taste?
So this turns out that this object came from the so-called local standard of rest, and that is the frame of reference that you get to when you average over the random motions of all the stars in the vicinity of the sun. So it's sort of like the local galactic parking lot. And just like cars near a city center are moving relative to the parking lot, stars move relative to the local standard of rest. And Oumuamua was at rest in the local standard of rest. So the relative motion relative to the sun was the motion of the sun relative to the local standard of rest. And that was very unusual, because only 1 in 500 stars is so much at rest in the local standard of rest. So if Oumuamua came from another star, why didn't it inherit the motion of that star relative to the local standard of rest? That was quite unusual. And if you ask me what could be, if it's artificial, what could be the reason for that? Well, you can think of objects like Oumuamua being placed in interstellar space at rest in the local standard of rest, so that nobody would know where they came from, because no star has that velocity, of the local standard of rest. Very, very few stars have. And you can perhaps use a grid, an array of those objects for navigation. Just like road posts, as you navigate through interstellar space, if there is a grid of those objects, you can tell where you are. Another possibility is that they are relay station for communications. And that's another possibility. So at any event, it's unusual to find an object in the local standard of rest, and that's one of the 6 peculiarities of Oumuamua.
So local standard of rest is measured against the velocity of the sun?
No. So it's basically you take the velocities of all the stars in the vicinity of the sun. Each of them is moving in a different direction. There is some random motion, and you average those, and you end up with the local standard of rest. Now the sun obviously moves relative to that frame, but Oumuamua was at rest in that frame.
Okay, and so it's Oumuamua has an abnormal velocity compared to other objects that are in the same area or may have entered from another galaxy. It's unusual.
Yeah, it's unusual at the level of 1 in 500. So only 1 in 500 stars is so much at rest in the local standard. It's a very special frame of reference to be at. It's sort of like finding a car that is parked in the parking lot that you have in the middle of a city, where there is only 1 in 500 stars that are parked at rest, and all the others are moving around in the street, in some random motion, and just fine. So if this object came from a star, it's very unlikely to have been at that speed. So that's peculiar. Why would it be so unusual? That was one of its anomalies.
You also talk about Oumuamua possibly being a light sail from another civilization. You mentioned in the book that it could be an alien light sail. Could you describe for someone who's not familiar with light sail technology, because you work a lot with light sails with the Starshot initiative? What is a light sail? How does the technology around a light sail work? And what makes you think that Oumuamua could possibly be of the same technology?
Right, so a light sail is very simple. It's just a film of material, very thin layer of material, which reflects light, and therefore being pushed by reflecting light. Just like a sail on a boat is being pushed by reflecting air, by reflecting the wind. So light carries momentum. It can push something when it bounces off it. And if you make a thin enough layer of material, the reflection of light is sufficient to push it. And we are currently developing this technology in the context of, as you said, the Starshot project, which aims to visit the nearest star on a journey that would take a couple of decades. The nearest star is 4.25 light years away, and so it takes light 4.25 years to get there. It's Proxima Centauri, and they only got the results of the 2016 elections in February this year. So it's a long distance, and to get there in, let's say, 20 years within our lifetime requires a spacecraft that moves at 1/5 of the speed of light. And that means 1,000 times faster than the chemical rockets that we've used before. A factor of 1,000 is huge. It's roughly the improvement in speed between Sputnik or all the spacecraft that we launched into space relative to the first car, the T-car that Henry Ford invented. A factor of 1,000 is a lot, and the question is how to achieve it, and the only way to get to a fraction of the speed of light is by using light to push on a sail, which can bring it, in principle, to the speed of light. So, for example, in the context of Starshot, we are planning to use a very powerful laser beam focused on a sail that has roughly the size of a person, that weighs roughly 1 gram, and so that it will be pushed to 1/5 of the speed of light within a few minutes. If the
So it's
laser
super
is
thin. It's super thin. The
yeah.
entire thing is the size of a person, and it's super thin, shaped like a sail. What is it made out of, or what are you
Well,
trying to
that's
make it
one
out
of the
of?
challenges we are working on, and there are several materials that are highly reflecting. You don't want to absorb more than one part in 100,000 of the laser power,
Hmm.
because otherwise it will burn up, it will heat up and burn up the sail. So you need a material that is highly reflective and also very strong in terms of material strength. And we identified a number of such materials. That's not a big challenge actually. We already have some materials that can do it. The issue is really creating a powerful laser beam, that is 100 gigawatt or so. That's a challenge in terms of the cost. You want to do it at a cost that is reasonable. And the other challenge that is quite substantial is communication. Once this spacecraft gets to the nearest star, 4 light years away, if it beams back the photograph that it takes of, let's say, a planet near
Hmm.
Proxima Centauri that is habitable, like Proxima b, there is such a planet, then the beam of the signal will get spread, and the signal will be very faint when it reaches Earth, and
Hmm.
we need just a big telescope that will be able to detect it. So that's a big challenge as well, and we're working on these issues of what we call the photon engine or the laser beam,
Hmm.
the sail, and the communication right now, and we want to figure out whether there are any showstoppers at this moment, and if there aren't any showstoppers, then we could move to the next phase, which is the
Hmm.
demonstration, a system that will demonstrate the
Hmm.
technology.
And the object, if it carries an object like a chip to record data or project something back to Earth, that would also have to be extremely light as well, because you mentioned it's
Right.
1 gram. So that this wouldn't be for transporting large objects or people or anything like that.
Not at this point, if you want to get there in 20 years, but you can imagine bigger payloads that are pushed at a slower speed initially, that could carry people with the
Yeah.
same technology. You can imagine that. And in fact, if another civilization, for example, has a transport system between two planets like the Earth and Mars that
Hmm.
is based on light sails, then we could potentially detect the beam of light when it sweeps
Hmm.
across our sky. That would appear as a flash of light that is leaking through the sail, and we could see it.
Hmm.
So when two planets are along our line of sight, that's exactly when we would see that light beam, and it's something to look for, to search
Hmm.
for such signals. That would be interesting. I should say this project, Starshot, is being funded right now by an entrepreneur from Silicon Valley, Yuri Milner, and we hope that it would lead to a future technology, and we're currently working on it. I'm the chair of the advisory board
Hmm.
for this project.
Yeah, that's exciting, and it something else that is exciting is the possibility of other life that your book and the discovery of Oumuamua brings into the Overton window of conversation. You mentioned there's a lot of pushback in the scientific community about not the actual evidence itself, but a lot of the refusal to kind of explore the possibility of it being from another civilization. And at the same time, I see a lot of comments and uh, positive, exciting comments from people that leave comments on the interviews that you do on YouTube. When I was preparing for this podcast, other people that are tweeting about it. There's a lot of positive excitement about the possibility of encountering another civilization or even an object from another civilization. And you actually wrote an article titled "What should we do if extraterrestrials show up?" So I will ask you, what do you anticipate our first encounter to be like? What should we do if another civilization made it known on a global scale that like we're here, we're showing up, and because a lot of people think it may have already happened, some people think it will never happen. So what do you think we should do?
Well, first I should say that if you're not allowing yourself to find wonderful things, you will never discover them. So the worst that can happen is for all the scientists to ridicule this possibility of doing space archaeology, looking for relics coming close to Earth, so that we will never search for them. It's just like saying everything is rocks out there. And to me, that is just like the mentality of a caveman that when presented with a cell phone would say that's a shiny rock. Because the caveman is used to playing with rocks all of his life. And that would be unfortunate, because that would be a self-fulfilling prophecy, like stepping on the grass and saying, like, look, it doesn't grow. The alternative would be to fund the search for objects that may be plastic bottles among all the rocks that we find on the beach, and we should fund such a search at the level that we are funding searches for dark matter, the matter that makes the universe, that is the biggest constituent in the universe. We don't know what it is. There is 5 times more mass in matter that is invisible compared to ordinary matter. We don't know what its nature is, and we are investing in trying to find what it's made of. And that frankly will have very little impact on our private lives, but we should at least invest similar amounts of funds in research, targeting interstellar objects, trying to figure out what they are, and every time we see something different that looks like Oumuamua and doesn't look like Borisov, we should get more evidence about it. So I think, the interstellar travel takes a long time. It's very difficult for biological creatures like ourselves, astronauts, or animals to survive such a long journey. They're not designed for that. We would suffer a lot of damage to our body from cosmic rays, from other risks in space. So we are not fit for very extended journeys that would take a very long time through space. And therefore, I think most likely, if we find evidence for another intelligent civilization, it would be in the form of equipment or signals that indicate equipment. So the point to recognize is if there were starshot probes going through the solar system, that weigh 1 gram, like we are designing now, we would not recognize them. They would move too fast, the fraction of the speed of light. When astronomers see something moving so fast across the sky, they would dismiss it. And frankly, they would not even see it, because if the size of the object is the size of a person, a few meters, it doesn't reflect enough sunlight for it to be noticed by existing survey telescopes. So it's quite possible that there are lots of things flying around that we haven't yet noticed, either because we are not sensitive enough, we don't have telescopes sensitive enough, or because we dismissed those. I can give you an example that when I was very young, when I started doing astrophysics, I remember going to the library and looking at volumes of the Astrophysical Journal, the main journal of astrophysics, and all volumes had photographs of clusters of galaxies that had big giant arcs of light around them, and nobody paid attention. There were these arcs and people just ignored them, even though it was on the photographs. And in the 1980s, suddenly the subject of gravitational lensing became popular, even though Einstein already discussed it 40 years earlier. But then it became sort of popular in the 1980s, and then people said, oh, these arcs around clusters of galaxies are just the gravitationally lensed images of background galaxies that are being stretched into an arc. And suddenly they noticed something that was already documented and said, oh, that is a gravitationally lensed image of a background galaxy. So what I'm trying to say is, the data sometimes is not interpreted. And if you're not allowing yourself to look for something unusual, you don't find it. So claiming that you need extraordinary evidence and it's not in existence is the wrong approach, because if you're not looking for it, you will never find it.
So if that evidence, if we come upon conclusive evidence that another alien civilization is making contact with us or trying to make contact with us, what should we do? What do you think should be the next steps of humanity when we have something that we agree upon from a scientific analysis that yes, this is not of Earth for almost certain, and now we need to proceed with the next steps? What would you say we should do?
Right. So, well, if we detect signal or find a piece of equipment that indicates another civilization, it would be prudent to figure out what the purpose of this was, and what does it imply about the intentions of the other civilization. Because when you go in the wilderness, you want to listen and figure out if there are predators out there, and that could risk your existence. And so if it happens, well, first of all, you want to understand what the equipment is doing, and or if there is a signal, what does it mean? And that brings a host of questions about communication, because we don't know their language, and we need to figure it out. And it's just like breaking codes, in the military, when you have another nation transmitting signals that are coded, and you don't know the code, and you want to break it. You need the same skills as trying to figure out a language that is foreign and the meaning behind the language. So that would be really fascinating. It will be, I call this frontier astrolinguistics, trying to figure out what it means. What is the meaning behind the signal that you found? And we'll have
that's a fascinating thing to think about, that there will be a field of study in the future where people are trying to become competent at interpreting other languages that aren't of this earth, or other signals, and that's what people do. You get a degree in astrolinguists, which it seems crazy to think about now, but I mean, why not? If we are making contact, or other civilizations are making contact with us, the best thing we could do would be to try to interpret that data as quickly and as efficiently as possible, so that we can see the nature of it. Is it harmful? Is it hostile? Is it positive? Is it in between? So yeah, that's fascinating to think about.
Exactly, and that will not be the only new field. There would be astroarchaeology, or space archaeology. There would be a lot of interesting new fields opened up. And by the way, there is a film related to this issue of communication called Arrival. And
yes,
I was fortunate over the past few months. I had a lot of conversations with artists, jazz musicians, filmmakers, all kinds of writers. One of the filmmakers was the producer of Arrival, and who was quite interested. He read my book, Extra-Terrestrial, and was interested in discussing it. And I told him that, that was my favorite film, Arrival, because it shows this problem, the philosophical issues associated with interpreting the language of aliens. And in fact, it's not just the language, it's also the means by which the words are delivered, or the communication is delivered, which if you've seen the film, it's actually ink or some visual content that you have to figure out. And I was actually quite flattered that he paid attention to my book and found it interesting, and I expressed my admiration to the film. And by the way, as a result of all these conversations, I realized that there are a lot of similarities between innovation in arts and innovation in science, and we benefit from each other. And in both cases, when you have innovative ideas, they are not appreciated immediately. It takes time, because it takes people out of their comfort zone. And however, I should say in my case, I had a tremendous positive response from the public. from people that are not engaged in academia, and especially young people from all over the world. And I get a lot of messages every day about my book, and that gives me a thrill, because I do realize that eventually these young people will occupy the halls of academia, and they may lead to a change in the culture that we have right now.
Yeah, Arrival is fascinating because I've seen the movie and I love it as well. It's fascinating because it's the directors and editors' interpretation, director, producer, editor, everyone involved, their interpretation of what First Contact could be like. And so when you let your mind run wild creatively and you're forced to put that within the boundaries of film and screens and something that people can consume, it's like you're making your own theory of this is what I think First Contact could be like. And so when we have artist interpretations, we have creative interpretations of First Contact, maybe that helps us recognize the actual First Contact because we've had all these creative interpretations, kind of like in science fiction, when science fiction authors who have little to no background in science actually write about scientific innovations before they happen, like the internet, like AirPods, artificial intelligence,
Jules Verne came up with submarines, and
it's fascinating to think about the combination of science and creative science and art coming together and actually benefiting from each other.
Definitely, our imagination is often limited to what we have experienced, but the artists, and the writers can dream up things we haven't experienced yet, and by that expand our imagination. And as I said before, if you're not allowing yourself to find wonderful things that are beyond what you experienced in the past, you will never discover them. And when there was a lecture about Oumuamua at Harvard, and I left the room with a colleague of mine that worked on rocks for many decades, he said, Oumuamua is so strange, I wish it never existed, which in my mind is contrary to the spirit of discovery. Because
he said it. I wish it was so strange. Your colleague said, "I wish it was so strange that it never, or it's so strange. I wish it never existed."
Yeah, that's what he said.
That's a weird line of thinking.
Well, it's not weird if you think from a point of view of someone that wants to feel comfortable to stay within the same framework of thinking, right? And that's what most scientists would prefer, to just get data that confirms their prior notions, right? So for example, when quantum mechanics was discovered about a century ago, it took a lot of people out of their comfort zone, and including Albert Einstein, and he argued against the interpretation that quantum mechanics has spooky action at a distance, he called it, something that we've never seen before. And Einstein resisted that, but later experiments demonstrated that he was wrong. And here we are, a century later, after quantum mechanics was discovered, still not fully understanding the interpretation of that of quantum mechanics. But nature is whatever it is. It doesn't care about whether we feel comfortable with it or not. If we have neighbors, we have neighbors. We can shut off the screens. Or we can close off the windows and not look through the windows and not see our neighbors, but it won't change the reality that they exist. And you can decide to live in your home and not read about the news of what happens in the rest of the world. Just worry about your immediate neighborhood. Guess what? Even if you get your food through the front door, what happens in Wuhan, China, will end up affecting you eventually, even if it comes through your front door. So not knowing what is out there, may keep you in your comfort zone, but only for a little while, because eventually it will come to haunt you. I think knowledge is always good because it helps you plan and protect yourself. And if you just think about the dinosaurs, they were very proud of themselves. They had huge bodies and they ate grass and they felt dominant and relative to their environment. But then a giant rock the size of Manhattan Island showed up in the sky 66 million years ago and killed them and wiped out the 3/4 of life forms on Earth. And it was obviously good for them to know about it in advance.
Yeah. To go back to the statement that your colleague made, that kind of pushing away strangeness. It's so strange. I wish it didn't exist. It seems like pushing away strangeness, or the refusal to acknowledge strangeness or weirdness, is the opposite of innovation, and it's a poor mindset to have, it seems like, as a scientist, because anything that is innovative, before it becomes widely produced and changes the world, whether it's knowledge or an actual applicable technology, it seems strange because nothing's ever been like it before. People see it and they're not sure what to do with it. Maybe people are developing it and it's not like anything they've ever seen before, but innovation comes from the thing that is not exactly like the other. And so if you're pushing away strangeness, if you're pushing away weirdness, in a way it's like you're rejecting any sort of innovation, because you're saying the filter of what's acceptable to me is only going to be things that are like the other, like the things I've seen before.
And you know, that is very unfortunate, as you say, but it's prevalent in the academia. And I have many examples of that. You know, for example, continental drift was rejected for 4 decades. Heredity, you know, the idea of genetics was rejected for many decades. You know, Vincent van Gogh in the art, you know, his painting, he was considered a madman during his life, and then his painting style was adopted by expressionists, and then he was later recognized as a genius, and his paintings are sold now at the highest value of any art. And you know, for another example in astronomy, Cecilia Payne-Kapashkin, she was an astronomer that wrote her PhD about the sun and argued that the sun is made mostly of hydrogen, at least the surface that we can see. And that was rejected because people thought at the time that the sun must be made of the same materials that the Earth is made of, because the Earth is a leftover from the sun formation process. So during her PhD defense, a prominent astronomer, Henry Norris Russell, who was the director of the Princeton University Observatory, told her to take this statement out of her thesis. And she took it out, and then 4 years later, he tried to check her result and concluded that she was right. And it just shows you, you know, that, as you said, initially, the initial reaction is to reject something and ridicule it and push back against it. And, you know, there are many such examples, that even the discovery of hot Jupiters, the idea that a Jupiter-like planet may exist close to a sun-like star, and therefore, you know, we could detect it by the tag, the gravitational tag that it gives the star. That was proposed in 1952 by an astronomer, Otto Struve, and for 4 decades, nobody followed on that, because people said, oh, we know Jupiter must be very far away. We see it in the solar system, far from the sun. Therefore, you shouldn't expect any hot Jupiters. But in 1995, a couple of astronomers found the first one, and they got the Nobel Prize a few years ago for that discovery. And you may say, okay, well, it's only 4 decades, and what's the big deal? You know, eventually they found it. My point is, for any baby that was barely born, you know, after 4 decades, and there are many such examples that I mentioned, there must be a lot of babies that were never born, because the mainstream continues to push against those and not allow them to be born. And how many lost ideas that could have brought us to a much better knowledge by now.
It seems like a lot of life, and I've felt this in my own life, is an exercise of becoming okay with your weirdness and being willing to dive into that and express that in a way that's interesting to the rest of the world. And it seems like from your work especially that being comfortable with exploring things that are weird or things that are we haven't seen before is an advantage as a scientist, for sure.
Right. But you realize that I can do it because I have a secure job. I have tenure at a prestigious university like Harvard. A young person that is looking for a job would be quite worried about making a statement that is out of the box, because that could endanger his or her job prospects. So what you need is people that have job security, people that get tenure in academia. You want them to free their mind to explore, risky directions, to innovate. But instead, what you see almost all the time is that once people get tenure in academia, they try to protect their image. They want to maintain an image of not making mistakes, not taking risks, so that they can get honors and awards. And they keep repeating things that are already known. And that's unfortunate, because they are the people that should not worry as much as the younger people. And by creating an atmosphere of this type, they discourage young people from innovation. So I think a culture that is much healthier than that is one that promotes innovation, that rewards people that are willing to take risks, because we rely on those risk takers for making new discoveries.
Yeah, I want to go back to the connection between art and science for a moment, because you mentioned that your favorite movie is Arrival, and there have been so many different depictions in pop culture of aliens, whether it's Alien vs Predator or District 9 or other television shows. What specifically about that movie makes Arrival your favorite depiction of aliens in pop culture? Is it the language that they use? Is it the way, kind of like the atmosphere on the spaceship? To you, what stands out about Arrival that kind of drew you in creatively?
Well, first of all, there was no major mistake in the physics. And very often what bothers me in science fiction is that the storyline violates the laws of physics. So I have a problem enjoying it when I know that whatever is shown cannot happen in reality, because how can I enjoy something that makes no sense?
It's kind of like a soldier watching a war movie that he knows it looks completely fake. So
exactly.
That makes sense.
So Arrival, in a way, didn't have that problem. And in fact, when I spoke with the producer, he said that indeed they were very attentive to the scientific details, trying to make the storyline as plausible as possible. So that's point number one. And then the other thing is that it addressed a philosophical question of great importance: how to communicate with an alien civilization. When you meet another person, you can pretty much assume that this person has ears, eyes, and a nose, the way you do, just because you share a common genetic heritage. But when you meet a life form from another planet that had no contact with Earth, it could be very weird, something completely unrelated to what we have here on Earth. So this is a fundamental question of how to communicate with something like that. And the movie is doing a good job in discussing the problem, And of course, it was also appealing to see, visually what is happening in this film. And altogether, the entire package was very appealing to me.
Yeah, we sometimes we even have trouble communicating with other people that we view as quote unquote weird on this planet, and so communicating with someone that does not share our language or characteristics or even the same time scale which they have to deal with in Arrival, it's a fascinating look. And speaking of laws of physics, because you mentioned that one of the reasons that you enjoyed Arrival is because they follow the laws of physics. One of the mysteries in physics right now is what happens inside a black hole. And I wanted to ask you, I wanted to pick your brain, what fascinates you about black holes, because you're an expert in black holes. You study, write, and think enormously about black holes. What fascinates you about black holes? What do we know about black holes? And what would be your best educated guess as to what goes on inside when stuff gets sucked in?
Right. So black holes are quite amazing in the sense that they represent the structures of space and time. According to Einstein's theory of gravity, space and time can be distorted by objects, by mass. Sorry about that.
No, it's okay. So you're saying they could be black holes could be distorted by space and time?
No. So according to Einstein's theory of gravity, matter distorts space and time.
Got it.
So
okay.
matter tells space and time how to curve, and then space and time, the curved space and time, tells matter how to move. Now, the most extreme distortion of space and time is in the context of a black hole, where you create a region that once any object gets into it, it cannot escape. Even light cannot escape from it. It's the ultimate prison. So there is this so-called event horizon surrounding this region, and if you imagine boarding a spacecraft that will cross this event horizon, you would never be able to transmit any signal that your friends back on Earth will receive. There is nothing that can escape from that region, and that makes black holes fascinating, unlike everything we've seen anywhere else. You can escape from the Earth. We do that with spacecrafts. You can escape from stars, but you cannot escape from a black hole. And the question is, okay, matter gets in, but what happens to it? By the way, we do have an image of the shadow of a black hole that was obtained a couple of years ago, and it was actually obtained at the conference room of the Black Hole Initiative, a center at Harvard University that I'm the founding director of. And that's the first time we imaged the shadow, simply associated with the fact that light emitted behind the black hole is getting absorbed by it, so it appears as a dark shadow in the sky. And this shadow that was imaged is of a black hole that weighs 6 billion times the mass of the sun in a nearby galaxy called M87. So that's quite amazing. But at any event, there is still the fundamental question of what happens to matter when it falls in. And I was wondering about this question when the basement at my home was flooded one day, and I asked the plumber to come over and figure out what's going on, and we found that the sewer is being clogged by tree roots, and then I thought to myself, I've never realized that the water actually goes out of the house somewhere, and I was just ignored this fact, and I thought about the analogy with the black holes. Matter gets into a black hole and it must go somewhere. There must be a collection place where the water, the matter that comes in goes to. And the question is, what is it? And according to Einstein's theory of gravity, there is a singularity at the center of a black hole. And that's simply a place where Einstein's theory breaks down, because when matter falls in, it gets to a very high density, almost infinite density, and then Einstein's theory just breaks down, cannot really deal with that. And we know why it fails, because it doesn't incorporate quantum mechanics. And obviously, if we had a unified theory of quantum mechanics and gravity, we could have forecasted what happens near the singularity, and the singularity will go away. We would figure out. So singularity is simply a place or a time where we can't really forecast what happens based on the Einstein's theory of gravity. And, and so there's a conjecture.
Yeah. There's nothing. I was going to say there's nothing in physics right now that can bridge the gap between the laws of physics that we know, the theory of relativity, and what goes on inside a black hole, the quantum mechanics, extreme situations of gravity. There's nothing that unifies those two.
Well, there are attempts that people are pursuing, like string theory or quantum loop, gravity. There are various proposals for how to unify quantum mechanics and gravity, but none of them is making a specific forecast as to what happens near the center of a black hole. They are unable to do this, to make that calculation. And the bottom line is we don't know. And the same holds for the Big Bang. The Big Bang, the universe is expanding, and if you go back in time, there was a point in time where the density of matter was infinite. And it was everywhere infinite. So it was simply a point in time that was very special, and that's the Big Bang singularity. Again, singularity in Einstein's theory means we can't really use the theory to forecast what happened before the Big Bang. But if we had a theory that included quantum mechanics and gravity, we could have perhaps avoided that Big Bang and figured out what happened around that time. And so, unfortunately, we don't know. So that's one of the mysteries. And in the context of the black hole, you can imagine two situations. You can imagine an object near the center of a black hole where all the matter collects, just like a town reservoir, a collection spot where you collect all the water from all the sewer, that comes in.
Did you see?
Yeah.
Sorry, go ahead.
And then another possibility is the matter goes somewhere else, and like another universe or somewhere else, and we just don't know.
Did you see there were a bunch of articles a few days ago about the first spaghettified star wrapping around a black hole or spotted?
Yeah, it was not the first. I mean, for
or was it the first that we observed, or am I
No,
am I
there
getting
were
that wrong?
examples before that.
Okay.
They just tried to exaggerate the case for this set of observations, but we had evidence for stars getting spaghettified, and if you imagine, I mean, the Milky Way galaxy, our own galaxy, has a black hole of 4 million times the mass of the sun, and if a sun-like star would come close to within 10 times the event horizon of this black hole, it would get ripped apart and become spaghettified, basically become a stream of gas that will circle the black hole and eventually be swallowed. And so the same thing can happen around the black holes at the centers of other galaxies. And by the way, that is only happening if the black hole is not big enough, because if it's like M87, the black hole there, any black hole bigger than 100 million times the mass of the sun simply swallows the star whole, and you don't see any spaghettification. But smaller black holes, less than 100 million times the mass of the sun, can spaghettify a black hole, a star passing close to the black hole. And
what was special about this recent occurrence then of a spaghettified star? I'm reading an article where it says spaghettified star wrapped around black hole spotted for the first time. Why would they say it's the first time if it wasn't the first time? Or if you've looked into this recent one at all, what was special about this one where there are a bunch of publications about it?
Well, probably they got better data than we had before, so they had more data on this event. But definitely there were many other events before that that were good candidate events for the same phenomenon. So this is not
so they're exaggerating then when they say the first time.
They're exaggerating that it's the first. Yes, definitely. This is a field where you can find publications about events like that dating back a decade at least. I had a PhD student that worked on it a decade ago and wrote papers where there was already some literature on observational results over the past decades multiple times. So this is not a new discovery. I mean, maybe the data on this particular event is much better than it was on other events, but we do see such things. And it's interesting because a star getting ripped apart by the strong tidal force of the black hole creates a flare, and we can learn something about the environment of the black hole from that flare. But coming back to your original question, other than the nature of the singularity, there is another big paradox that we don't understand about black holes, and that is called the information paradox. When you imagine an encyclopedia that carries a lot of information, let's say a book, we don't need anymore these encyclopedia books of Britannica. We can throw them into a black hole. So imagine throwing them into a black hole and all this information gets swallowed. Now, by itself, that's not a paradox, because when you see a cat walking behind a building and you suddenly don't see the cat, that doesn't mean that the cat doesn't exist. The information was lost. No, the cat exists, it's just that you can't see it. So when the encyclopedia goes into a black hole, it's not a paradox. You just can't see it. It's still there. But the problem comes from the notion that was originally pioneered by Stephen Hawking. In the early 1970s, he showed that the black hole evaporates. It evaporates into radiation that doesn't carry this information. And he basically showed, even though a black hole is a prison, it cannot confine radiation that cannot be localized to the black hole. It has a wavelength bigger than the size of the black hole, and basically continuously leaks radiation, and that is called Hawking evaporation. And so eventually a black hole evaporates and disappears. And the question is, if it's not around anymore, if the building is not around anymore, you should see the cat. But where did the information go? If the black hole disappears and the radiation that was created doesn't carry the information that fell into the black hole, so where is that information? That violates a fundamental law of quantum mechanics, that information cannot be destroyed. And that is a puzzle that physicists are working on, trying to figure out either whether something was wrong in Hawking's calculation, or maybe the radiation that comes out that carries that information, maybe there is some other solution that has to be figured out.
Yeah, so it would be kind of like a building that collapsed and the rubble, like no one could find any trace of the rubble or dust or metal pillars, whatever. So when a black hole evaporates, there's no information, nothing, no traces, no kind of rubble from the absorbed left behind.
The rubble is the radiation that is emitted when the black hole evaporates, but you can show that this radiation doesn't carry the information that fell into the black hole. And that's really the paradox, that the radiation carries very little information. So you start with the black hole absorbing all this information, and then it evaporates into very little information. And the question is, where did it go? And that's the information paradox.
Yeah. Could it be that it's turning it into something like dark matter that we can't observe, or it's kind of invisible to us? Or
one possible suggestion that was made over the years was maybe there is some remnant left of the black hole that encodes all this information. That's not a very popular idea right now. People trying to find out, ways by which the radiation coming out of the black hole actually does carry the information. For example, if you throw something to the sun, it burns up, but the information that went into the sun is still carried by the radiation coming off the burnt material. You can figure it out. And so it's possible that the black hole emits the information in some way that is subtle, and people are trying to figure it out through a detailed calculation. It's not yet proven.
Yeah. So in your book, you warn about the danger of considering abstractions that are separate from the data. And so with something like the information paradox of the black hole, there's only so much we can observe, or so much we have the technology to observe right now. And then once we hit that limit, we're forced to abstract, we're forced to come up with theories, things that may not have evidence to back them. And when I think of abstractions in science, I think a lot about psychedelic experiences. There are creatives and scientists that talk about the benefits of entering this abstract world through psychedelics that is a separate slice of reality, and then they come back and they're infused with this new point of view or new just something kind of clicks where they come back to the data and they're able to look at it in a different way that may lead to another innovation in science. So I was wondering, for you, what are your thoughts on psychedelics, and if you have any experience or if you know colleagues that have experience with psychedelics and its combination with scientific innovation, if you have any thoughts on that?
Well, I know of artists that I personally never had any such experience, but I know of artists that had experiences, but not scientists. And I should say, science is guided by evidence, by data, and there are two ways to make progress. One is to try and get data. So in the context of black holes, you can imagine, suppose we find a black hole that evaporates, you can do an experiment and measure what it emits and try to learn more about it. You can also learn about what happened around the Big Bang, try to get data about, the instance just very close to the Big Bang. People are talking about detecting gravitational waves, ripples in space-time that were generated very early on in the universe. That could give us information about the time when quantum mechanics and gravity had an interplay. And this way you can actually test ideas about unifying quantum mechanics and gravity. So either in the context of black holes or in the context of the early universe. So we can imagine circumstances that will allow us to get data that will test these theories. And that is one path to pursue, trying to get data, okay? The other approach would be to say, okay, we just don't have the data as of now, let's focus on other problems. There's so many challenges that we can try and figure out. Why worry about the problems for which we can't we can't collect data? Why spend our life on something that we cannot test? I have a problem with science becoming a monologue, where you express your views about nature and never put it to the test, never put skin in the game. Because you don't really learn about nature just by expressing what you think, by doing mathematical gymnastics, by showing that you are smart. The experience is similar to, the two of us sitting in a room and enjoying the idea that we are very wealthy, that we have a lot of money, we can do whatever we want, without doing the experiment of actually going to the bank and trying to cash out on this idea. Because if we try to do that, we will realize that through this experiment, that our idea, even though it's very appealing and pleasant and makes us happy, is not real. So being a scientist is really putting your ideas up to the test. I can give you another example. Bernie
I wanted to pause on the money example for a moment. So that raises an interesting question about science and philosophy and the limits of thinking abstractly versus paying attention to the evidence. And I would push back a little bit and say that outside of things, outside of situations where you have evidence to test things and test what you think and test your theories, I do see that there's value to having abstract conversations for extended periods of time that may lead to a better understanding for when we have the technology to test for that evidence. So for example, for the wealth thing, for centuries people have been talking about what a decentralized money system could look like. And we did not have the technology to implement a global decentralized currency until blockchain came along. and when blockchain came along, we had hundreds of philosophical ideas and interpretations of money, what money is and how it worked, that we can apply to the technology when it comes along. So I do see a value in thinking abstractly, whether that's science or not. It's not science because there's no evidence. I can't test it, or the technology isn't there to test it. But I do see a value in kind of letting your mind run wild creatively, so that in the future there may be ways to test out those abstract thoughts.
Yeah, I completely agree with you. But I think there should be a balanced spreadsheet, in the sense that, you have some of these, but at the same time, you're also working on things that are testable. So if you put all of your attention to ideas that will never be tested during your lifetime, as some scientists do, then you're at risk of spending your life on things that are, completely irrelevant. So you want to avoid that. I mean, obviously, I completely agree with you. There is value in pursuing such ideas, but at the same time, you should not put all of your attention to such ideas that are not tested during your lifetime. Because, another example is Bernie Madoff. He promised people that he will give them back more money than they give him. And that was a beautiful idea. And people loved it. And they gave him the money. And the only problem came when they asked for the money back. And he had an issue with that, because reality did not resemble what he was promising. So he was put in jail. That's called a Ponzi scheme. Now, how do you tell a Ponzi scheme that looks beautiful and appealing and everyone is happy about? How do you tell that it's a Ponzi scheme? Only by testing it. So you are at a risk of spending your life giving your money to someone that has beautiful ideas, unless you're testing them. And you don't want to put all your money in schemes of this type that promise you a return without an experimental test. Okay, so what you want is you can allocate some fraction, and you can regard it as a risky approach, some fraction in that, but you want also to invest in bonds, things that will that are much more viable and are testable.
Yeah, I agree with the balance aspect, that it seems like if you don't have a balance of thinking abstractly and also working on things that you can test in reality, and test in this reality as we know it with our senses, then it's hard not to get caught in the theoretical Ponzi schemes where you can't really test for it. And that brings to question another thing that people grapple with, and it's hard to tell the difference sometimes, the difference between beauty and function, and the fact that things that are beautiful aren't always right. Just because something is beautiful doesn't mean that it's functionable, and doesn't mean that it's correct, and doesn't mean that it's valuable beyond beauty. There are things that are in art that are valuable because they're beautiful. And then there are also other things, like you mentioned the theories, that yes, a theory can be beautiful, but also part of a theory is that you want it to function in reality. And that's where you would want to draw the line between, okay, yes, this looks good, this is sexy, this is aesthetically pleasing, but like, how does this work when you actually apply it?
Well, a good example is Aristotle's world of having spheres centered on us. That was an appealing world model because it was centered on us. It gave us the privilege of being at the center of the world. And it was also a beautiful model because it had those spheres, and spheres are perfect shapes. And so for 1,000 years, people believed Aristotle. And that's a good illustration of a theory that prevailed and was flattering the ego of a lot of people, and people were happy about it. But once it was put to the test, it ended up being wrong. And my point is, we can talk about extra dimensions and the multiverse as notions that appear to be quite sophisticated and mathematically challenging and we can work out, we can demonstrate how smart we are by performing complicated calculations. But a notion that, like for example, that an object was artificially made doesn't require very fancy math, but if it's real, it carries much more weight than the mathematically sophisticated notions of Aristotle's world or of extra dimensions.
Yeah, that's true. Just because something looks good doesn't mean it actually works in the world that we know it. So you mentioned Stephen Hawking before, and you've actually written about Stephen Hawking and his effect on your life, and how he taught you how to embrace life. And I wanted to ask you, what was your relationship like with Stephen Hawking, and what are the most important lessons that you've learned from him?
Yeah, I met him multiple times. The first time when I was very young, I was asked to carry him up the stairs at a conference because there was no elevator, and
Oh, wow.
it felt like carrying a child because his body weight was very light, and I admired him since that time. I was in my 20s, and then the next time I saw him was at the Royal Society in London during an event, and his caretaker approached me and said, Stephen is bored. He has nobody to speak with. Would you mind speaking with him? Because I was the only scientist in the hall. And so I went to speak with him, and I invited him for the inauguration of the Black Hole Initiative at Harvard that was planned half a year later. And surprisingly, he asked his doctor to join us, and the doctor agreed. The only problem was to get $500,000 to bring him over on a special airplane, but I managed to arrange that.
How did you arrange that? That's crazy. So he required a special, like a private airplane to bring him over?
Well, it was known what kind of an airplane is needed. The question was to get the funding for that. And
Okay.
at first I called the dean at Harvard, the dean of science, asking him for advice. I said, can we organize some event that would raise the funds? And the dean said, no way, because it also requires a liability for his health, and we can't do that. So then when he hung off the phone, I thought of another idea, and a few days later I secured the funding. Basically we invited him for the public announcement of the Starshot initiative in New York City, along with the inauguration of the Black Hole Initiative. And he came for 3 weeks, and he also came to my home for Passover dinner, and that was a very interesting event. Because, he ate everything my wife made for the dinner, and also gave a special speech, and he came in some group of cars that included security personnel, and we invited them as well to the dinner, and that was quite useful because one of the guests brought a bottle of wine that fell on the floor, and they immediately jumped at it and cleaned the floor within a few seconds. So having those security personnel at dinner was quite helpful.
Nice.
It saved our carpet at home. But overall, I should say my biggest inspiration from Stephen is the fact that not only he contributed to physics in a fundamental way, as I mentioned before, black hole evaporation was his major contribution, and people before him didn't think that black holes have a temperature and they evaporate, they emit radiation. So that was a major breakthrough in our understanding of black holes. But beyond that, and if I had to speculate, I would say that last year the Nobel Prize was awarded to Roger Penrose, and very likely if Stephen Hawking was alive, he would have gotten it as well. That would be my guess. But the other thing that is even more remarkable about him, that he was always optimist. He always thought about the fun of living, and if you think about it, he was unable to move his body. So during the pandemic, I developed a routine where I jog every morning at 5 a.m. And in one of the mornings, I fell on a rock because it was slippery, it was rainy. And I basically had to be rushed to the hospital and had blood all over my face, and they put bandages.
Oh, geez.
I came back home at midnight, and the following morning again at 5 a.m. I started jogging with my bandages, and it gave me a glimpse of what is it to have a physical disability, which is very minor compared to what Hawking went through. And just thinking about, most people would be depressed by not being able to move a muscle, not being able to speak, but not only was he able to function, he had this sense of optimism about enjoying life. When he came here, one of the evenings after a party, he told a public event, he told his caretakers, let's go to the bar at the hotel and have some fun. And that shows that he enjoyed life. And I don't know of anyone that would be able to approach life in such an optimistic way, given the limitations. I call it the Hawking limit. I wrote a Scientific American article about the Hawking limit. This limit of the human spirit being completely detached from physical disability.
Yeah. I totally agree with the keeping perspective when you're physically incapacitated, and then when you're physically incapacitated to a limited degree, and then you think about people like Stephen Hawking who weren't able to basically move at all and needed machines to help them speak. I had a couple elbow surgeries back when I was still playing baseball in school, and I was feeling sorry for myself at the beginning where I was like, I'm not going to be able to use this elbow, this arm for a few weeks. And what helped me kind of look beyond that was, I'm going to have access to all four of my limbs next month. A lot of people, they may get their arms blown off completely in war. They may lose multiple limbs. They may not be able to use their limbs because of nerve issues, things like that. And so that definitely helps me keep perspective as well.
Yeah, and the other thing to keep in mind, we will not be around a century from now, you and me and many others that listen to us. So, we should enjoy every moment that we can. Life is a gift, and most people just they ignore the fact that they take it for granted, so to speak. And
this podcast is a simulation, so I'm just an artificially generated life form. So I'll be around forever. I want to respect your time because we're about 8 minutes over. Do you have time for one more quick question?
Please go ahead.
So this is actually the most popular Kindle highlight in your book, Extra-Terrestrial. When I was going through my own highlights and then flipped over to the popular, this is the line in your book that's highlighted the most number of times. And you write, over the years, I've come to believe that the laws of physics cease to apply in only two places, singularities and Hollywood. So my very serious question as we leave off is, what is it about Hollywood that defies the laws of physics? We talked about singularities and black holes. What about Hollywood for you defies what we know about physics?
Well, what I meant is the storylines of science fiction that sometimes do not obey the laws of physics. It's not that the laws of physics do not apply to those films. It's just that the storyline does not follow the laws of physics. And as a result of writing my book, I was contacted by more than 25 filmmakers and producers from Hollywood, and they showed interest in the book. And if I, as is likely the case, I will collaborate with a partner over there, and if we produce a documentary or a film, and I will try to make it as scientifically accurate as possible. So there is a way, and as we discussed in the context of Arrival, there is a way of expanding our imagination through the arts with a narrative that is not violating the laws of physics. And I think that's the most admirable path to take, because you are still constrained within, what we know, but you're allowing your imagination to branch out beyond what we experienced so far.
Well, thank you, Avi, for your time. I admire the way that you approach science and life in general. You've inspired me to think more openly, be more accepting of weirdness and strangeness, and be open to innovation and the possibility of encountering alien technology. And I'm excited to keep track of your work and keep track of the work in that area in general. And thank you again for your time. I really appreciate it.
Thank you. You made my day. I should say, if you want to follow on my
Yes,
work, then I have a Scientific American essay posted every week or two. And also on my website, if you put my name, Avi Loeb, on Google, you can get to my personal website that lists all the publications that I put out, and some videos of my appearances in various programs. And I hope you will enjoy it.
Yes, I will link all of that for people watching and listening. I'll link those in the podcast description. I went through many of those videos and articles on Scientific American. I'll put a link where it brings you to all the stories and pieces written by Avi Loeb, and you can go down and go through those on Scientific American website. So thank you again for your time, and I'll talk to you soon.
Thank you. Thanks for having me.